Okay, is my screen visible?
Yes.
Okay, thank you. So week 7 is about so there are two components to this week's topics. One is generalized linear models. The second one is k nearest neighbors. So we are going to go over the activity questions first. Okay. I think there is some printing error in this particular question, and I see some of the next questions also. Okay. Is this understandable to you?
Actually, when I saw it, it looked different. It looked proper.
I see. So maybe something is wrong with my browser setting. Let me refresh and see. Oh, no luck there. Okay. Okay. So if it is not understandable, maybe I can skip this. So this is this particular question is about identifying the correct pattern of exponential family formula. And so if you're familiar with LaTeX, probably you can still identify which one is the right answer. Can anyone guess which one should be the right answer?
I had solved it.
Okay, okay. So this \exp stands for E. This is actually eta symbol raised to the power minus T. Ty is your sufficient statistic. Eta is your canonical variable. And okay, so one thing I can tell is this one has to be wrong because this is T, this should be T of Y, not T of Y minus 1. This one has to be wrong also because there is a negative sign. So first and second option remain. It should not be minus T, it should be C.
I mean,
So, pardon me?
No, third one, I had solved it earlier. So for me, it looked perfectly fine. Otherwise, I wouldn't have been able to solve it. Third one is the right one.
Okay, okay.
It has a minus AN, right? The third and fourth has plus AN, which is wrong.
Right, right. So third one should be the right one. So I hope that in your, so this is only the case with my browser, not with yours. So nothing is wrong with the configuration, only some browser setting is misplaced. Because of that, it is not showing properly. Question number 2, the quantity e raised to the power, okay, this is becoming difficult for me, plays the role of normalization constant.
Yeah, it's a straightforward answer. What is the normalization constant? So okay, comes to 1, yeah.
Bernoulli and Gaussian distributions belong to exponential family, whether it is true or false.
True. How many percent? Okay, am I the only one talking? Okay. Okay.
Yeah, it is true. Yeah. I think sir has explained this in the video also and derived a formula for Bernoulli and Gaussian distributions. Let's check the answers. Okay, we got all of them right.
This is the video.
Yeah, this is the video. Let's go to the activity questions. Okay, so Roth-Mac regression is a classification method or not? So it is. Okay, so this question just yeah, it is true. Softmax regression, though the regression name appears over there, it is actually a classification technique. Next one is softmax regression generalizes logistic regression. True or false? Logistic regression by default it takes care of. Okay, so what do you think? Is it whether it is true or false? I don't want to give too much hint.
It's true. Yeah.
It's true. Right, it is true. Question number 3. The loss function used in the case of softmax classification is?
Yeah, the answer is categorical. I guess that's because there are more than one category, right?
Right, exactly.
So is the difference between binary and categorical, is that the only difference? Binary is for 2 labels and categorical is for more than one.
Yes,
two.
yes. Yeah, that's the only difference. Let's check. Yep, that is true. So we got all of them right. Let's go to the third part. Okay, there is something wrong. KNN is a discriminative classification method, generative classification method, instance-based classification method, or all of the above. Which one should be true? Hello, am I audible?
So instance-based classification method.
Absolutely right. So instance-based classification method, that is true. So before we proceed, can anyone tell me what is the training step in KNN, classification or regression, either?
Training step is just storing the instances.
Exactly. So it doesn't do anything else, but just remembers the instances which are available in training dataset. Right. If it were generative, then it would have tried to learn something about the instances, positive and negative both. If it were a discriminative classification method, it would have tried to figure out the differences between those two. I mean, two classes. So both A and B are incorrect answers. C is the right one. Question number 2. KNN technique can be used for classification. Which one of those two? Regression or classification? Both of them.
Both.
Both. True. So if it is classification task and let's say K is 5, then out of 5 we take the majority class. So 5 nearest neighbors get to vote on what should be the label of this new data point, and all 5 of them vote, and whichever label gets highest votes is chosen as the final answer for that new point. For regression, we apply a different technique. We cannot do voting. We apply either mean strategy or median strategy, because the output that we are supposed to produce is continuously, and that's why we use either mean or median. So it is true. We can use KNN for classification as well as regression. Okay. KNN classification technique is okay. So I think I should read. Sir, is this also coming exactly like this, or it is printed properly in your browser?
Everything is proper. I mean, because I finished all the activity questions. So.
Okay. Only I am seeing 2 Ks over here.
One sec. Yeah, 3, right? Let me just check it again. Yeah.
Sure.
Yeah, K-NN. Perfectly.
Okay. So something's wrong, definitely wrong with my browser only. So as long as it is printing correctly in your browsers, that's fine. We can go ahead. So question number 3 is K in K. So the proper wording for this question would be K in KNN classification technique is K is number of classes, K is number of nearest data points based on which we decide the class of the new data point. K is the number of distance measures used. Which should be the correct answer?
Number of distance measures.
Exactly. No. Number of distance measures.
Sorry, number of nearest data points. Sorry.
Yeah.
I want to say number of distances used. Yeah. Number of nearest data points.
Right. For too small K, KNN model will underfit, overfit, or just fits right.
This actually, I know the thing, but I have to ask. I had a thing. Underfit is the right answer, but I want to. Sorry, overfit is the right answer, but I was trying to. I couldn't wrap this in my memory. I mean, I couldn't understand why it will overfit.
Okay. So consider that KNN is So what it does is it takes for
Because it's
regression
like it's the
task.
opposite of polynomial, no? It's like polynomial. If you have too high a degree, it overfits.
Right.
So,
So there, if k, I mean, in the polynomial regression task, if the degree of the polynomial is very high, it is likely to overfit because the model is too powerful.
okay.
Right here, what is happening is, so if the model, in that case, the model is too powerful, then there is a huge variation in predictions. What happens if in Canaan model, what happens if k is too small? Let's say k is only 1. So it looks at the nearest neighbor, and whatever the value that neighbor has, it gives it as output. So maybe I should pick a diagram. Maybe with the help of that, I should explain better. So in that case, what we can so Canaan is like uh, it is taking average of k nearest points. So it is, first thing is, if k is very small, for example 1, then it would just take that value and give the answer. That means there could be too much. One thing is, it is too powerful because it is not taking. It is just taking one opinion of one of the neighbors, and that's it. It is giving it that as the output. So it is missing the pattern. It is possibly missing the pattern which is there in the underlying data set. So
So
give me
that's why
one
I'm
more.
thinking the answer should be underfitting. No, I was in this way.
So underfitting is like okay. So see, what happens is, if k is small, then our predictions on the training set, what will happen? They will be always true. That is right. They will be always correct, and the error will be 0 on training set. Do you agree?
Even there, in the boundary, the error may be high, right? Near the boundary, it may just look at the wrong thing.
Near the boundary, near the decision boundary, yes, the error could be high. But for the sake of this particular question, let's assume that you are training a model, Canaan model, k is 1. Then what will be your training error?
Yeah, training error could be very low. Okay.
Actually, it will be 0. Right?
Okay.
Because for every training data point, you know what is the
same
right
point.
answer.
The same point will be there. Yeah. Okay. Same point will be there. Yeah.
Right. So your training error will be 0. But what will happen to your validation error or test error?
That could go high because we have not learned anything.
Exactly. So it is not trying to learn the underlying pattern through its neighbors. So it is just taking one point and giving the output. So your validation error will be high. Your training error will be low. So these are symptoms or signs of overfitting. That it is doing very good in training, but it is doing very poor on new data points.
Got it. So that way, that by the definition, okay, should apply the definition. So underfit, overfit basically means very low training error, but high
Prediction error.
Prediction error. Underfit means both are high.
Exactly. So overfit for, I hope this helps.
Yes, definitely. Yeah.
Okay. So let's go to next question. For too large k, Canaan model underfits, overfits, fits just right. So I think we can apply the same line of argument and try to understand what should be the answer for this one.
It will be underfit.
It will be underfitting. Yes, because in this case, so let's say for the extreme end of the other spectrum, what we can say is k is equal to the number of data points. So it is always going to give you the average of all the values that are available in the data set, a training set. It will always predict just one value. For all training points, all validation points, it's going to give you just one output. So in that case, what you will see is the training error is also high, along with the test error, validation error. So it is classic example of underfitting. Okay, let's go to next question. As value of k comes close to total number of okay, so actually it brings up to the our argument led to the next question. As value of k comes closer to the total number of points in the data set, what is going to happen? The model will predict label of minority class for every possible example. The model will predict the label of majority class for every possible example. The model will predict label of actual class for every possible example. What is going to happen?
The majority class, because that is what will contribute to the maximum, right?
Exactly. So yeah, so let's consider an example. There are two classes, class A and B, cats and dogs. So there are 100 samples of dogs and 50 samples of cats. So if k comes close to the number of data points in the data set, so k, let's say it becomes 150 or 140. So for every new image, every new sample, it is going to compare it with 150. It is going to look at the 150 nearest neighbors, so which is actually entire data set. And in that data set, 100 samples belong to dogs class. That's why it is always going to predict dogs. So even if they, the new sample could be closer to the other 50 cat examples, and the rest of the 100 dogs samples are actually further away, still, since we are going to take, votes of 150 nearest neighbors, so dogs class is going to dominate. So it is going to predict the majority class for every possible example. Okay, we got all of them right. Okay. Which of the following can be used as a distance measure for Canaan classification?
Both Euclidean as well as Manhattan.
Right, absolutely right. So
and then the MLP, he gave a few more also.
In naval practice, okay, right.
The parameter can be many more, right? So yeah.
Yes. So of course, Euclidean distance and Manhattan distance, both of them are usable way of measuring distance between a pair of points in Canaan. Okay, question number 2. Find the Euclidean distance between 10
and 20.
And 20. Okay, so this is getting tricky for me to understand.
Yeah, so
okay.
10 column, 20 column.
Okay. So Euclidean distance 10 and 20. What should be the answer?
So should be 2 minus 1 square, all that's basically 1.
Okay. Right. And find the Manhattan distance between 1, 0 and 2, 0.
Yeah, same.
So in this particular case, both of them are same. For a regression task, the output prediction is calculated as average of the outputs. So, okay, before we proceed, anybody has any questions? How are we quickly calculating Manhattan and Euclidean distances?
I don't have any questions, but if there are others, yeah, because this is there in the assignment also.
Right. Okay, so just to increase our level of interaction, is it okay if I call somebody by name and discuss one of the questions? Okay, I hope there is no problem. Parth? Hello, Parth, can you hear me? Okay. What about Gautam? Gautam, can you hear me? All right. Shorja.
Yes,
I hope
I'm
I'm
here. Yes.
Shorja.
Yes,
So
sir.
I hope I'm pronouncing your name correctly.
Yes.
Okay. So Shaurya, so far any questions?
Sir, I have not actually, finished my lectures yet, gone through all the lectures. So I don't know what is Manhattan distance yet. So that is
I see. I see. So I'll quickly tell you what is a Manhattan distance.
Yes.
So what if there are, let's say, n number of features, not m for Monday, m number of features in your sample. Then what you do is you take the difference of a feature-wise difference of every value in your two samples, take the mod of them, and then sum them. That's it. That's Manhattan distance. Okay, so that's why 1 0 minus 2 0 gets minus 1 0, and you take mod of both values. Minus 1 mod is going to give you 1.
It's basically like the L1 norm.
Exactly.
Okay. Yeah.
Yes. And Euclidean distance is like calculating
the
distance
norm.
between.
Yes.
It's similar to L2 now.
Yes.
Yes. Okay. Thank you, Shaurya.
Yes.
Okay. Okay. Let me pick a new name. Celine, are you with us?
Oh, yes, sir.
Okay. So Celine, can you tell what should be the answer for question number 4?
Sure, sir. Sir, I have no idea, sir.
Okay. So for a regression task, the output / prediction is calculated as average of output labels for k neighbors. Okay. So what it is asking is, if you have a regression task, how are you going to, and you have k neighbors, k nearest neighbors, their corresponding labels, then how are you going to predict the output based on the labels of those k nearest neighbors? So, Sajin, can you tell me what is regression? What is the regression task?
Sir, actually, I've just joined, so
I see.
Yeah, I watched up to 7.3 right now.
Okay. So, did you come across this term regression?
Yes, sir.
Okay. So, do you remember what that is? Okay, no problem. So regression is one of the, I'm just going to give you a quick definition of what that is. So regression is one of the supervised learning tasks that we perform in ML. And the important point about regression is that the output that we try to predict is continuous value.
Oh, yes, sir, I'm back. Oh, yeah.
Okay. Supe Tushar. Thank you, Salim, by the way. Supe Tushar. Vaidehi. Debargya. Debargya. I hope I'm pronouncing the name right. Okay, I think so. Okay, for this question, anybody would like to take a call? What should be the right answer? Question number 4.
It'll be because for regression, you're going to calculate, so you'll take the average of all the neighbors. Right?
Then it should be true, right?
Yeah, true.
Okay. Question number 5. For a classification task, the k neighbors take part in voting. the class that receives the highest number of votes is the predicted class, whether it is true or false.
Yeah, it's a maximum of the classes that they look. See, the maximum classes among the neighbors. So that is true.
Exactly right. So this should be true also. Question number 6. KNN is sensitive to redundant or irrelevant features since all the features are used to compute the distance between the 2 points. Is this true or false?
Yeah.
False.
Okay. Go ahead, Celine.
Yes, I just wanted to say it is false.
Okay.
Should be false. Yeah.
Should I go ahead and mark false, or anybody would like to say something else?
No, I felt it. I mean, I decided as true. I finished the activity questions. I know that answer also, because if you have many features that do not participate, right, unnecessarily, one is of course you're doing the computation plus
Right.
the sum of them. Finally, they might go influence your results.
Absolutely. Right. So that reasoning, I agree with that reasoning. So if there are features which are irrelevant or redundant, what is going to happen is they are going to add to the distance between a pair of points and could possibly influence our predictions. So yes, it is true that KNN is sensitive to redundant or irrelevant features since all the features are used to compute distance between 2 points.
In the demo, sir uses an extreme thing, right? He takes MNIST and takes it to 2 features, 784 to 2. So
Yeah.
that's a very
Yes.
drastic reduction.
Right. Okay. So our answers are all right. Celine, I hope that explanation you agree with that.
Yes, sir, I understood. I thought it would be sensitive because outliers will matter, but then, yeah. I've not watched the video, so it's okay.
Yeah. So KNN is slightly robust towards actually outliers. Just to add a point, because
Okay.
whenever you are measuring, there is a new point that comes in, and if you take the distance of its k nearest neighbors, so outliers typically are the ones which are lying outside the normal range or purview of the data points. So it will be far away from the point that we are trying to make prediction on. So KNN in that regard is more robust towards outliers.
Okay.
Okay.
So that is why if a very weird question, like now if you are comparing like two pictures of numbers, digits, so if a very weird drawing will come up, so it won't predict because it is not sensitive, right?
Celine, can you expand that question a little more?
I just like till now what I watched, he had shown those digit like images of numbers in the first video. So if let us say that is our input to the data, to the model. Okay, so the output, if a very weird image is given to the model, it won't be able to predict, na? Weird in the sense like a 3 is what do you say, like a ulta 3 is given, so it won't be able to predict, like the mirror image of 3.
Right. So it will predict possibly, it could predict wrong.
Yeah, because it is not taking in outliers, right? So it won't model.
It is not taking outliers.
As part of the model, it is not taking in outliers. I mean, it is not, the model is not sensitive to outliers, right? So
yeah. So
if I just extrapolate what Celine mentioned, so suppose you give a mirror image of 3, it is very likely to put it as 8.
Yeah, so
because it won't differentiate between the white space that is missing in that and the rest of the white space. all other white space will constitute, and then it will just predict this 8. No? Or
Yes, yes.
Just
So,
a doubt, like it's just an observation. It may be wrong.
yeah, sure. So, for example, let's say when you say outliers, I would say, let's say we have all the numbers. For example, the zeros, they are centered at the, for example, they're centered, properly centered. But somebody draws a zero, which is, slightly or significantly left shifted or right shifted. So in cases like that, probably Kanan is going to make a bad prediction.
Yeah.
Right. Okay. So this session for activity questions are so this session is still so let's discuss the practice programming questions. Oops, the answer is already there. I thought we tested it. So write a function Euclidean a comma b to find the Euclidean distance between vectors a and b. Both a and b have shape and cross 1 n by 1, where n is the number of features / dimensions. So the input of your function should be vectors a and b. The output would be Euclidean distance between vectors a and b. Okay, so for this, okay, this one, let me delete it. Okay. Okay, so any thoughts? How would you go about solving this problem?
We could just subtract the vectors and compute the dot product.
Subtract the vector and do what?
Compute the dot product.
Yeah, so that somehow doesn't work. I don't know why that thing does work. So I was also very confused because it seemed to challenge all my numpy. Mine was also that basically a minus b whole squared, right?
Yeah.
Okay.
And,
right.
But that did not work.
So Euclidean distance you have to take. Okay. So what we'll have to do is okay. Let me write something on a pad, scratch pad. Okay, is my screen visible?
Yeah.
Yes, sir.
Okay. Okay, so let's say we have two vectors, A and B. So A is, since it's n cross 1, that means it's a column vector. So for the sake of simplicity, I'm going to write it like this. Transpose for B would be something like 3, 4, and 5. Transpose of that. So Euclidean distance, so it's a 3D space we are talking about. So both A and B belong to R3 since there are 3 dimensions. So in order to calculate the Euclidean distance between these 2 points, first thing that we'll have to do is A minus B, which is going to give us minus 2, minus 2, minus 2. Okay, what next step should I take?
We have to take a norm of this.
Which norm?
L2 norm.
Yeah, normal
Second
norm.
norm.
Yeah.
Right. So what I do is 2 square, which becomes 4. This also becomes 4. This also becomes 4. Then what do I do?
Sum it up.
Sum it up. Right. And then?
Ideally square root, but none of that worked.
Yeah. So square root is the right answer. It should be. So it should be 12. So it will become 2, 3. Okay, so now we know what, so this is a brief refresher of how we are going to calculate Euclidean distance. The point comes down to this, how we are going to implement it in NumPy,
Yes.
right? Okay, so any takers, how should I start?
See, I was thinking it should be no axis, nothing need to specify it, but unless I put axis equal to 1, it did not work.
Okay, unless we put, no, without axis equal to 1, we can also make it work. We can use numpy dot sum. Yeah, numpy dot sum should work.
Okay,
So
for me,
are the vectors n cross 1 or just n? Means are they one-dimensional arrays or two-dimensional?
the problem says n cross 1. The problem says they are n cross.
That means we have to unpack it into one single 1D array, and then we can do the dot product.
I don't think that's necessary. We can do it without it, right? Without unpacking it.
We can just sum the resultant vector as well.
So are you saying that if I just ravel it, I can just apply this method, it will work?
I think so. I should.
So without raveling also, okay, let's implement it. I think there should be no need for raveling, but let's see. So we import NumPy.
Yeah, so now you are in, sorry, yeah, okay, you're writing here, okay, import NumPy.
Would you like me to code?
No, that's okay. NumPy is NP, yeah.
Yeah. So next thing is we are going to get that function. So definition Euclid.
Yeah. It be just as easy, right? I will understand. X1, X2, AB.
A and B. Okay. Yeah. So now we know that they are n cross 1. We know that the dimension is n cross 1. Then what we are going to do is, let's say there's this another vector C, which is the difference between A and B. So okay. A minus B, right? Very similar to what we did over here. So these two steps are equivalent. Next, what should we do?
Okay. So now we have to, so this is where that axis, I have to put axis equal to 1 so that I sum each column or each row, so, right?
Axis equal to 1.
No, suppose I can't say A minus B whole square, right? I can't say C square. That's not the right thing.
Right. We are dealing with vectors. So there is a slightly different notation for that. Yes.
Okay.
So what we can do is, okay, and tell me what should I do?
So I tried C dot T into C.
C is equal to C dot T
at
right.
That is what you're saying, dot product, right? Yeah. Or NP
yes.
dot CHC.
Yes. So I think it should work.
So just say NP dot CC and it should work.
Right. The only catch
and sum of it, yeah, sum of it and then square root.
Yeah. So the only catch here will be you don't have to take the sum. The only catch will be what will the dimension of C in NumPy?
It will become 1.
Hello. So that's an interesting catch. Now I'm getting what would have stopped you from using this approach right away.
Oh, because it is still an array. I won't get a scalar. I won't get a
scalar. Right. And it's a two-dimensional array actually. Yeah. Interestingly, it is going to be two-dimensional approach. So would you want me to demonstrate through a proper code?
I think I get it, but yeah, it would be useful for others also to demonstrate it. But yeah, it's a very simple problem, but the NumPy is where I got really it tested my NumPy skills. NumPy knowledge. I mean, I don't have much skills, but it just tested my NumPy knowledge. Yeah, exactly. I was getting an array and I couldn't figure out how to get it to a scalar. Yes. Finally, the answer is a scalar, right? The distance is a scalar distance.
Yes. The final answer has to be a scalar quantity. But the way NumPy works is this quantity is not going to be a scalar. It is going to be a two-dimensional matrix. Interestingly. So think about it like this. So dimension of this would be 1 cross n, and dimension of this would be n cross 1. So your final product of multiplying these two is going to give you a matrix of 1 by 1.
1 by 1. It is still a vector.
This,
Even though it is a 1 by 1.
it is still a matrix, right? In order to get this quantity, so you will have to do something like C 0 0 to get the scalar quantity.
Okay, got it.
Yes,
Okay,
sir.
so let me show this quickly with an NumPy code. Okay, I hope my screen is visible.
Yes, sir.
Okay, so first thing that we do is we import NumPy, import NumPy. We have two arrays. A is equal to array. Let's make it 1, 2, 3. We have another array. B is equal to NumPy dot 3, 4, 5, and there it is. C is another A minus B, another vector, and we get C. C is this. Okay, so far this is not exactly how the problem is, because A and B, both of them are they have to be reshaped to match the dimensions mentioned in the question. So it would be -1, 1. Similarly, B should also be reshaped. -1, 1.
Just as a
Now,
curious thing, can I do it
yes,
in the initial thing itself? When I set up A, can I make it, can I say axis equal to 1 and then get it this way?
which one in this method?
Yeah, see, we are only define the AP, A, right? Can I define A itself so that it comes as a column vector rather than a row vector?
Yeah, sure.
How do I do
So,
it? Just say axis equal to 1, A equal to NP dot array 1, 2, 3, axis equal to 1.
NP dot array axis. No, without using axis, we can do that. Actually, we can initialize it as a column vector. Okay. So, sir, are you seeing this one?
Yes.
So this is the format for actually defining the vector in a column vector.
Oh, okay. Put a vector of it. I mean, array of arrays. Okay.
Exactly. Yes. So you can see that there are 3 rows, row 1, row 2, row 3, and in each row we have only one value, so it's 3 by 1.
Okay.
Okay, so now let's come to our calculation. C is equal to A minus B. So this is going to give us a column vector again. Now our job is to figure out the dot product. So let's store, for the sake of demonstration, the dot product of C transpose and C into variable D, and we are going to get this, something like this. And if I try to see the shape of D, it is going to give me 1, 1, and number of dimensions of D, it is going to give me 2. So something we have to take care of if we are going this way. We can still get the answer by taking NP dot square root of D 0, 0, and there is our answer. So that is one way of doing it. I hope this is clear.
Yes, sir.
Okay. The other approach would be when we have C is this one. What we can do is we can do D is equal to C square. Now we got this, and now we know that it is going to be 3 by 1 array. So what we have to do is we have to do the summation. We have to take the summation of all rows. So the answer, or summation, I should write summation is equal to
We have to set the
np dot,
axis is equal to
exactly,
0.
exactly, axis equals 0. So this is going to give me the summation value is 12.
Oh,
It is still,
yeah, axis equal to
yes,
0 because I'm adding all the rows. No.
yes, adding all the rows. Yes,
Yes,
exactly.
axis is equal to 0 is basically the sum throughout the columns of each column. And axis is equal to 1 is the sum of each row.
But it should be either way. It should be, even sum should also be the same because there is only one thing, right? So why will sum give a different answer? That is what I got stuck.
No, it is not. It should not give you a different answer, because by default, if you don't provide axis value, it takes 0. By default, the axis value is 0 itself.
Okay.
So summation is still going to give you 12.
No, sir, but if you don't put axis, then the sum will be the sum of each element. In this case, it is a column.
Okay, let's try that one. Np dot arrange, let's say 1 comma 11, and we reshape it to 5 comma minus 1. Okay, and this is your t. Okay, t is this one. What so if I type hello, am I audible?
Yes, sir.
Yes, sir.
Now, yes, we lost you in between. Yeah.
Okay, yeah, there was some network issue. So yes, you are right. So when we actually do the summation of just call sum, it is going to give you the sum of all the elements, not axis wise. So both of these approaches will work, putting axis equal to 0 or without putting it. Hello. Sorry, I guess there was another episode of network issue. Am I audible now?
Yes, sir.
Yes, sir.
Okay, okay. So we were at the point. Did we finish the discussion? Were you able to hear me? That np.sum is going to give us the sum of entire set of elements in the array.
Yes, sir. We heard you.
Okay, okay. Now let's proceed with the next question. Okay, programming question number 2. write a function one hot y, which performs one hot encoding on vector y, and then outputs a resultant matrix which can be used for softmax regression as output label matrix. Y is a row. Sorry, it is written incorrectly. Y is a column matrix with n by 1 shape, where n is the number of samples. Okay. Example is, if y is equal to 8, 6, 3, its one hot encoding will be 0, 0, 1, 0, 1, 0, and 1, 0, 0. Okay, so before we proceed, can anyone explain me how this 863 is being encoded as this matrix?
We have to basically sort y, and then we have to do the length of NP unique, and then use the identity matrix.
Okay, okay. So any okay, so if we sort the y, so before we do it, that is right. So we have to sort. So the answers, the labels will become 3, 6, 8, and the label 3 is going to get the is going to get 1, 0, 0 label.
Yeah, we have to do NP unique.
Yes.
Yes.
And then 6 is second in the number, therefore it gets the second column, and 8 is the last value, so it is going to get the third column. That's right.
Is it enforced, or is it just a convention?
It's a convention. Yeah, it's definitely a convention.
Because this is just label encoding, right? If I'm not doing any ordinal, the numbers can be anything.
Absolutely right. They could be anything. So 8 could get the first column, 6 could get the third column, 3 could get the second column. That's
or
also
even
possible.
here, I can say that I'm varying the last column first.
Yeah, it's absolutely fine. That's also possible.
Okay.
Okay, so now question comes, how we are going to do this?
Yeah, so that suggestion will work, right? Take an NP unique and then identify, multiply it.
Okay. Okay, so let me open the whiteboard one more time. Okay, so we have this matrix, this label vector y, which wow. So y looks like 8, 6, 3, and our final encodings should look like so 3 goes first, 1, 0, 0, 0, 1, 0, and 8 gets the third column, which is 0, 0, 1. So this should how we are going to map this vector into this matrix. And more importantly, what are the operations? What should I do? What NumPy operations I should perform on y to get this answer? Okay, before we proceed, y could be anything. In this particular example, there are 3 values. So let's call our final answer as capital Y. That is what I'm looking for. So if I have this particular Y or any other Y, how would I get the dimensions of the matrix?
Y of 1, right? Y dot shape.
So Y dot shape, right?
Oh, no, sorry. First unique. Like I have to get the unique, and then length of the unique vector is the shape.
Okay, so NP dot unique. We are going to call on Y. This is going to give us what? Number of columns or number of rows?
It'll be the same, no? Because it has to be an identity matrix, right? That is a square matrix, no?
No, this need not be
because
an identity.
Okay, unique. Okay. Sorry. Okay. Yeah, it is going to give the number of columns.
Exactly. So this value is going to go over here. That is true. That is absolutely right. What about the number of rows?
That is ln of y.
That is
length of the y vector, the
exactly.
number of samples are there. Yeah.
Exactly. So if n by 1, n is the number of samples. So your shape of the matrix, so this, let's call it m.
Y dot shape 0 will be the length, first one.
Exactly. So this is the shape of the matrix. Now, how we are going to do this mapping? Now we know what kind of matrix we are going to produce as output. Now, how we are going to fill the entries?
If you have sorted it, just say equal to, and then multiply that with the identity matrix. That.
If it is sorted.
No. Sorry, I got confused. This is where we can use the array indexing, right?
Array in the.
We can use the array indexing to fill it with either ones or zeros.
Right. So so first thing, whether is this matrix is going to be sparse or densely populated?
Sparse, like only one. No, each row will be
exactly.
Have only one.
Yeah. Every row is going to have only one entry of 1. Everything else will be 0. Right. So for starters, what we can do is we can create our capital Y is equal to something like this.
NP dot
numpy dot zeros. Yes.
M by n.
N comma
n.
So now we know that the non-1 entries will, all of them will be 0. Now we have to figure out where to put ones.
Yes.
Okay. Now where should we put 1?
So I don't think that we need these zeros. I mean, we could just sort y. Then we first do an NP unique. Then we sort y and then do NP unique. Okay. So every element is in order. So so we replace y, each element in y with the index of each element in the sorted array. Okay. And then index the identity matrix.
And then index the identity matrix. Yes, that's a possible way to do this.
So basically, in this case, 863 gets transformed to 368.
Yes.
And then we replace 3 with 0, 6 with 1, and 8 with 2, which is the index of the sorted array.
Exactly.
Yes, and then we index the identity matrix.
So sorted y gets this value, and these are the indices in the sorted array.
Yes, and then we replace y.
Right. So y becomes, instead of what is it?
863. It becomes 210.
Exactly, 210.
And then we index the identity matrix.
So identity matrix of size?
NP n cross m.
N cross m.
Identity matrix of n cross m.
Oh no, no, we can't do that.
Okay, because ice is supposed to be a
exactly, it's supposed to be square. No,
you're
then we can do.
You're thinking in the right direction.
It should be n or m, I think.
Which one? That is also true.
No,
one of those.
Let's take an example with one row repeated, right? I think that.
I think m. It should be m.
Right, number of columns. Yes.
Number of columns.
Yeah.
Yes. So if we have, for example, in this particular case, n is also 3, m is also 3. Yeah. So the identity matrix that we are going to get is 1, 1, 1, 0, 0, 0, 0, 0, 0. Right. So the y becomes this, right? So first value in y corresponds to the second index entry in the identity matrix, right? So this will become, so since it is 2 and this is 2, index 0, 1, and 2. So I'm going to copy this value in my first row. The next index is 1. So I'm going to copy the corresponding row, which is this one in here, 0, 1, 0. And 0, which is corresponding to this row, I'm going to copy it 1, 0, 0.
Yeah, sir, if we can make a request, can we just make one more duplicate entry so that it becomes clear, so that the final matrix will be 4. So we
Absolutely, absolutely.
So make it
Let's
3683, right? 3683.
Okay.
It's the same thing. You don't have to change anything. You can just put it in the same way above itself. You can just add it.
Okay. So 8, 6, 3, and let's add one more 8. Will that be okay?
So above itself, you can do it, sir. You don't have to repeat again.
Sure. Okay. So
3683, then 0120.
3683. Okay. 01. So
That will be 012.
210.
Y will be 2100. Sorry, 2102.
Wait. 2102. Why it should be 2?
Oh, Y is 863, no?
So 3863 is my new Y. Okay.
Okay.
Got it. Got it. So it should be another 0 over here.
Yeah.
Okay. So there's this new entry 0. So it looks a bit different. So the first entry has index 0. So I'm going to copy this value into my first value this time. So it will become
on top,
1,
right?
0,
100.
0.
Yeah.
Exactly. So this should be my final answer.
Okay. So the indexing, we have to do it correctly in NP. NumPy.
Exactly. Now we have thought about the thought process, how we are going to convert it. Now we have to write the NumPy statements so that we get the correct answer.
Okay. So we just need Y sorted.
So first thing is we definitely want to sort Y, but we also want to keep the original order. Otherwise, if we have only sorted Y, then we will mess up the final output.
Yeah. So it has to be a new array, right? So yeah.
Yes.
Y sort equal to P dot sorted.
Actually, we don't have to sort Y either. We have to take unique values and then sort it.
Okay. Correct. Yeah, Y unique is sorted, YP.
Yeah, we can
Unique
do
of-
both ways. We can sort and then do unique, or unique and then sort. Same thing.
No, unique
Right,
and sort
but-
is easier, no? So that way sort is
Yeah,
unique
yeah,
is easier,
same.
faster, sort of a smaller array is faster.
Yeah.
So Y unique is equal to np dot unique of Y. Here we should write so Y unique has unique labels. Now sorted underscore Y. It is not exactly Y, but it has the unique labels inside Y. Which axis should I use?
Axis equal to. Do we need an axis? That's why I always get confused. Do we need an axis?
You tell me. Do we need it or not?
Yeah, I think we need axis equal to 1. Or this
one or
axis
zero?
really I tie up. I
Okay.
try both and then one works, then I use it.
It depends on what is the dimension
so-
of Y.
Y
Y is n
dimension
by
is
1,
two,
n
two
cross 1, right?
dimensions, right? N cross
N
1.
cross 1, that means it's two-dimensional. NDIM is 2. That means axis should be 1. Axis should be 0.
Right. Axis should be 0.
Axis
So,
should be 0.
Yeah. So for it, I understand that NumPy axis could be really confusing. So I'm going to give you a quick overview of how to remember this. You will not make mistake after that. So always, so it's, so it is like a convention in computer science. The 0, 0 is the left top corner. So whenever, if you have done any UI programming also, the pixel which is at the top left corner gets index 0, 0. Okay, and this is your x-axis, this is your y-axis, or in other words, this is your first axis and this is your second axis. And in NumPy, the indexing starts from 0. So the index of this axis is 0. The index of this axis is 1.
1. Okay.
Okay. So whenever you want to do operation in this direction, okay, so you want to sum up all the rows. You want to take mean of all the rows. You want to multiply all the rows or something like that you want to do. Any operation that involves rows, it has to be done in this way. So take one sample, add it to the next sample, the next row, and so on and so on. If you want to add all the rows, what you do is you provide index
X is equal to 0.
X is equal to 0.
Yes. Right.
And similarly, if you want to do operations with columns, you want to add all the columns, first column, second column, third column, and so on. So what you want to do is you want to do perform operation in this direction. So in this way, if you want to perform, you always give X is equal to 1.
Okay.
No, sir. Axis is equal to 0 sums up all the columns. Means we find the sum for first column, second column, third column, and axis is equal to 1 sums up all the rows.
No,
Yeah.
I think
So that's
you're doing the same thing, but I think you're saying it in the opposite way.
yes.
No. Means it's
Yeah.
it's actually
Yeah.
confusing. Means
No. What he said, what Sonin said is actually better. See, so if you're summing each row, what you're doing is you're summing along the columns.
yes.
So I think, but the first one is easier to remember, right? So you're summing the rows. So you're adding one row to another row to another row. So you will get that many number of columns in that.
Yes. The basic thing is if you want the sum of the columns, then we do X is equal to 0. And if we want the sum of the rows, then
Easy.
we want X is equal to 1.
There is a difference. So let's say if I write 1, 1, 1, so I have this matrix 1,
Yes.
for sake of simplicity, it is only two dimensions, 4 by 2. If I want sum of all columns, please pay attention to the wording. So this is my one column.
Yes.
This is my second column, right?
Yes.
If I want sum of all columns, I'm going to get 3, 3, 3, 3, right?
Okay. Yes.
Yeah. And the second thing I could say, I want to do some column wise. So what you want to do is you want to take sum of all the elements in one column, sum of all the elements in the second column. And if you want to proceed that way, it is going to give you 4, 8.
Yes.
Right. So when we do operations, when you put X is equal to 0, we are doing column wise operations,
Yes.
but not, yeah. So I think that the wording was the only thing which was confusing.
Yeah.
We both were saying the same thing.
Yeah, you're saying the same thing, but yeah, but we have to be very clear. Otherwise, somebody like me will get more. Yeah. So,
okay. So this is this explanation helpful for you to remember
yes.
how axes work? Okay.
So basically, a column wise sum is axis is equal to 1, and if you want the sum of each column, then axis is equal to 0.
If you want sum of each column, for
Means
example, if
elements
you want this
elements in the column.
if you want sum of all columns, right?
Yes, means the elements in a column.
Not elements in the columns. Sum of all columns means column 1, column 2, column 3, column 4. All of them you want to sum.
No, I'm not able to means put it across. I mean I want the sum of elements in one column. That means we put X is equal to 0.
Exactly right. Absolutely
Yes.
right. Yes. Okay. So what we want to do is we want to sort column wise. We have only one column, or I should not be confusing. So there's only one column, and we want to sort all the entries. We write S is equal to 0. So this is going to give us the sorted Y, and this is going to give us the so length of this RM is going to become length of sorted Y, or sorted Y dot shape in bracket 0, the first dimension of this one. Now we have to calculate, create an identity matrix. How am I going to do that?
sorted y, right? I np dot i's m.
Exactly. np dot I
Ey es or ey?
EYE. Okay. Now we have this I also. Now how should I proceed to get my final answer? Hello.
Sorry, I was speaking on mute.
Okay.
I np dot sort I index with y, and that I index with I.
np dot sort
I index with y.
Right.
No, that will not work, right? Not np dot sorted y, right? Whatever sorted y, I index with
So I'm still, so what answer should I get? So one thing's for sure, we are indexing I. What should I put in here?
index of the sorted y.
Indexes of the sorted Y. How? Okay. How would I get that?
Y of sorted y. No, that will not help. Sorted y of y. No.
Sorted Y of?
That I index. Can I index that with y? Y? No, right?
No, this will not work.
Yeah,
Because
you have more entries. Yeah, more entries
yes,
here. Yeah.
Yes.
Okay. In P. Okay. Yeah, the conceptually I can still see that I'm not completely grasped NumPy. There is definitely indexing. We need to do indexing here also.
Absolutely. Yes.
Okay.
So so let me help you. What we are going to need is, so we had 3, 8, 6 and 3. What we need is, we need a mapping 0, 3, sorry, not 3, 2, 1, 0. We need this kind of mapping. So if we have this Y, we don't have this. If we have this, we can just plug this into here and we can get the answer.
Yes. So is it y equal to np sorted y? Will that help work?
Y is equal to?
No, that will not work, right? They are not equal size, so it will not work, right? Yeah, if it's a dictionary, it is simple, but we don't have dictionaries here. So I'm trying to see how do I.
Yeah, so the other approach is by using dictionaries. That can also be done.
But that is easier. But let's try this, right? I give up. I give up. So I think it'll take me some more time to figure this out in my head.
Anybody else would like to say?
No, sir, this is totally out of my.
No worries, no worries.
You are creating this one-hot encoding, right?
Right.
But I done in a different approach.
Using dictionaries?
Not dictionary. What I done, so here we have 3863. I taken the max value. So we get 8. Then I added 1, that's called 9, right?
Sorry. Please explain that to me one more time. So you took the max value 8 and you added 1 to it. Okay.
Yeah, I added 1 and then I created one np dot, you can say zeros. Okay. So
okay.
In the and I have 4 columns. That means I need the 4 rows, right? 3 for 3, and 4. So I taken the shape of this as a 0, and then I have taken and the column value as a 8 plus 1, 9. So you are getting a 4 cross 9 matrix with all zeros.
Okay.
Right. And then what I done, I have put a enumerator on 3, 8 and 6, and I'm putting an I, and I'm putting in a loop.
I see. Okay.
Just to mean, because this multi-dimension, if putting comma y, that will not, if you have a you can say the internal nested loop or nested array. For that case, these multi-dimensions are not working. I was trying yesterday night. Then I found the simplest way to do it. But anyway, what you are saying, I want to learn this also.
Okay, so 386, if we do this, the way you mentioned 4 by n, okay, I'm getting your point, what you are trying to do. So,
but can we can if you can finish your approach, sir, then we can go to that approach.
Yeah, sure.
Okay, so this one is the main one. So I want to take a diversion over here. So let's say 0, 1, 2, 3, 4, 5, 6, 7, and 8. So what you are trying to do is wherever, so for first one is 3, 8, 6, 3. All of these are zeros. All the entries in this are 0. So you are putting 3 is over here. So you are putting 1 over here, 1 over here.
Right.
1 over here,
and multiple zeros, right?
And every other entry is 0.
Then I will put one where clause, and I will get all the zeros where sum is 0. I will delete it.
Okay. So this approach will work, but it is computationally more expensive.
Yeah, of course, agree.
Right. So what we want to do is we want to figure out the index. So basically, what we want to do is we have this number. We want to find out its index in the sorted array. That's all what we want to do. And if we have that, we are set.
Yes,
we can pass that variable inside this one.
Yeah.
But sir, in the second approach, in 0 to 9, that is not exactly one-hot encoding, because the number of unique classes is only 3.
See, right, but at the end, he is actually removing all the columns which have only 0 values.
Oh, okay.
So you will be left with this one. So maybe I should use some other color. So you will be left with this column, this particular column, and this column.
Okay.
Right? Yeah.
Sir, if you don't mind me asking, why did we add an extra 3 in the end or in the beginning, whatever?
For the sake of demonstration, right? We could have more number of samples than number of labels possible.
Okay.
So that we are clear on the n by m, right? Otherwise, everything is 3, and then we don't know which one to apply. Right? Okay, sir. Right. So can we look at your this thing? So this approach will work. It's a simpler one. How do we get the first approach, sir? Your approach?
Okay. Any takers?
No, sir.
Okay. So
we just means index the identity matrix according to the sorted positions.
Right. So that's what you want, right? How we are going to get the sorted positions?
Sorted positions, we can we do unique, then do sort, and we replace the y vector with the index in the sorted array. Means we have to do some programming in this sense. Means you have to check for each element and then replace it.
There is a way to do it without anything, right? I think that there is definitely a way, just with indexing alone. No, sir, I will give up. Yeah, I feel there's a simple way, but I can't think of it.
Yeah, I think
that might require some bit complex and numpy operations. I'm thinking of it. So 3863. Sorry. So 3863. What we want to do is we want to find it. We want to replace it with the index in another array.
We basically have to traverse the whole array in this case.
That is definitely, if we do that, that means our approach is exactly similar as that of find using the dictionary.
Yeah, we can also use dictionary. Yes.
So I'm trying to think. Okay, so before we proceed with this one, which could possibly lead us to more complicated answers, if we do the dictionary approach, let's do that for a minute. Okay, so if we do the dictionary approach, we have this dictionary which has, we have 3,8, 3,6,8 keys and corresponding 0, 1, 2. That's all we have. Okay, let's say. Right, if we have this kind of dictionary, all we have to do is we take this new variable, let's say new indices. Okay, what we do is for every I in Y, we are going to pass it through the dictionary,
Yeah,
and get the corresponding index.
Yeah. Yes, we'll get 4 indices.
Yes, we are going to get
Size of 4.
Size of 4, exactly. And what we are going to do, we are going to pass this into this one.
Yeah,
exactly. So it will become new indices, and that should give you the final answer. Assuming that this is actually a numpy array, we converted this into a numpy array so that in num indexing works flawlessly.
Yeah, that you can just do as NPS array, right? You just take this np.as array.
Yes.
Okay,
Yes.
but without thing. Okay.
Give me one moment. So I'm thinking about what operation should we perform on this one to get the answer.
So, can I look at the demo? He got it at 1, and I was tempted not to look into the demo, but I looked at the demo. He simply put, so we have put this, the initial, we have vectorized it, right? We have made it 0, no? What did we call it?
Which matrix?
We made a matrix of 0 y's, right? Y encoded is 0, right?
Capital Y, which contains all the zeros.
Yeah, capital Y. So he just put capital Y. Okay, indexed it with a range of len of unique Y and Y. np.a range len of Y.
Sorry. A range
Len of Y.
Len of Y.
The original Y, right?
Mm-hmm.
And the next parameter is Y itself. Next index, right? This is
right.
So this works, and I am now I'm.
No, but this problem. This will work because it's doing one mapping 1-to-1. But it has a you just proceed, then I will.
No, this is what he used. Actually, this is actually there in the demo.
Yeah, sir has used, but when you go for the practice question, it is not working. That I will tell. Let sir to explain. Then I will come. Sorry for disturbing.
No issues, no issues. So, why does this work? Do you have clarity on this?
Yeah, that is a clarity because it's mapping. Actually, when you put np.arrange, it is taking a length. So suppose, for example, here your length is 3, so it will put 0, 1, 2.
Length is 4. 3 or 4. 3, 8, 6,
0, 1, 2, 3. 0, 1, 2, 3.
0, 1, 2, 3. And in the Y also, you are getting the same exact value.
Exactly.
Then it is mapping in that position, it will assign that value 1-to-1. If it is repeated, again, it will assign the same value.
Right. So this particular one works if the labels are from 0 to K.
Yes, that is the correct. Yes.
right? So this particular case, it assumes that all the labels, the y, all of them are belonging from 0 to k. None of the values between them are missing.
No, we have 368, right? Those are the values. We are missing
Okay, so
values.
let's try that. Okay, so let's try that one. So what should be the dimension of y? It should be 4 cross 3, right?
Yes.
So initially all of them are 0. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And length of y is going to be 4. A range, this is going to give you an array of 0, 1, 2, 3. Am I right?
Yes.
Y is 3, 6, 8, 3, right?
Yes. Yeah.
So these, every pair is going to become an entry, and there we are putting 1. Yes?
Yes.
Now the problem is the index
Yes,
of
there's going to be an index
0.
problem.
Exactly, the indexing issue, because we don't have columns with index 3, 6, or 8. But we do have indices with 0, 1, and 2, and 0. So again, the problem is same. How do we get the column number for this particular value? This is what we want. So if we have this approach will still work.
So it will work only if the exact is 0 to k. Okay. This will work for binary labeling. Okay.
Not necessarily binary labeling. It will work for multi-class
that-
labeling also. As long as the classes are in increasing order without any miss.
Yeah.
Otherwise, we have to convert them into 0 to k.
Otherwise, we have to convert them into
0 to k.
0 to k. Exactly. So that's
Exactly.
that's what
We
we
have
want
to
do.
transform them.
Yeah.
So that way, then the dictionary approach is faster.
I wouldn't say faster. We have to have another alternative to say that it is faster.
Dictionary approach is basically order of n, means you have to check each element and replace.
In y, right? So number of elements, yeah, that.
Okay, so I think there are ways to do this, but they are far more complicated. To do it with NumPy operations only, without doing the without using the dictionary approach.
Using
Okay,
if you're using the dictionary approach, then that 4x9 column approach is also very similar.
4x9, I wouldn't still recommend it. That one is slightly even more time consuming, because so every time you remove a column, NumPy is going to create a copy of the rest of the columns. So
okay, the removal columns will be extra. Okay.
Exactly. So let's say you remove the first column, then you will get a NumPy array of this size. Then you're going to remove the second column. Then you will create a NumPy array of this size. Then you remove the third column, you get a NumPy array of this size, and so on. So you're not going to do it in one shot. You're going to do it repeatedly. So that would be that would take even more time. But for the sake of this course, and we definitely not going to take examples where we are short on time. We are going to take sufficient time to solve these kind of problems. Okay, I hope this discussion was useful. I'll take a little more while to figure out a less complicated solution to this one. There are some redirection approaches where we perform multiple NumPy operations and get the indices of these labels. Let me look at the simpler ones and I'll come back to you.
No problems.
Okay. Anything else we should discuss?
Sir, what will be the syllabus for the programming exam?
It will consist of all the topics for the first 4 weeks.
Only 4 weeks. Okay.
Yeah.
So can we get a mock to practice?
Yes, yes. You're going to get the mock over the weekend
Okay, thank you.
with all the instructions in there, so that you will know what to follow on the actual exam day.
So that is for both MLP as well.
Yeah. So you're going to get the mock
Yes.
test for ML practices also.
Okay.
And sir, is that the same as system compatibility test, or will it be different?
I have to look into system compatibility test before commenting on that. Yes.
Yeah, because it is scheduled for tomorrow and day after tomorrow. So I thought it will be same.
Okay. Okay. I have to check about that.
No problem, sir. Just asking.
Sir, one small question. I know maybe you have discussed and I missed this. The equivalent distance when we are calculating, when the sir as teacher, he is using the square root. Okay, even for the vectorized form also. But in the equation when we are solving it, we are not putting the square root. Is it correct?
Can you please tell me where we are not using it?
If you see the equation which we are using for the sir has used this equivalent distance, you can see there is nothing called np dot square root directly.
Okay. In order to find which are the closest ones.
Yeah, right.
Okay. Are you referring to the program?
Yeah, I'm referring to the program. Yeah.
I see. I see.
When you see the lecture.
Right. So I think that is because of the convenience.
Okay.
See. So let's say that there are 3 points, A, B, and C. A is the new point, B and C are known points. So distance between A and B is let's say square root of 4, and distance between A and C is square root of 6. Okay. Hello.
Okay. Yeah. Right.
So basically it leads us to 2 2 point. So square root of 4 is going to be 2, and square root of 6 is going to be 2 point something.
Right.
So we are sure that B is going to be closer to A, not C. Do you agree?
Yeah, I agree. No, that if you were putting a square root, but when the mathematical question will come, that time this square root can change your answer.
Absolutely. When the mathematical question comes in, please use the square root.
Oh, okay. Because there are some question in the practice and even graded. I asked whether we need to use the square root or not. Okay, thank you.
Okay. Yeah.
So we can leave now.
Any further questions from anyone?
No, sir.
No,
Yeah.
sir.
Okay. Then yes, we can leave. Thank you, everyone. Thank you for the lively discussions that we have today. And I hope that this slight diversion on NumPy accesses and everything would be useful.
Thank you,
NumPy,
sir.
I don't think there is enough. I mean, I can't spend enough time on NumPy.
That's true.
Actually, in the demo code, he uses that arg partitions, right? I tried to look it up.
Yeah, that is very interesting feature.
So confusing. I couldn't believe that he could just get it in one shot.
No, I dig that one, and it's very good for instead of sorting the entire list, you are just sorting a particular 3 or 4 value.
Yeah.
Yes.
To calculate the actual KNN, he just uses arg partitions.
Yeah, I'm talking about this arg partition only. Actually, when you put a sort, it will sort the entire list. But if you suppose your list has a lakhs of record, then if you are going to sort, it will take a huge time. Instead of that, if you use the arg partition and if you put 3 or 4, it will only partition the first. Means it will pick the 4 or 5, the smallest, and it will put in the first, and rest other it will not touch. So you are getting only the first shortest distance, 3 or 4, and that way the NP, that NumPy is working. Very good.
Yes, yes, absolutely right. So NumPy is, full of surprises when we are going to learn about it. There are a lot of things. There are a lot of functions also that are there.
Yeah, like example, sir, I use this state.mode. Okay, now we need to convert into NPPy. For that, we need to write 4 lines where stat.mode is doing in 1 line. So yeah, that's
Yes, yes. Okay. So any questions that you have on NumPy or any insights that you would like to share, that would be great. Post them on discourse forum. That is actually nice. Actually, we are also, even though we are in the team of a set of instructors, there are a lot of things in NumPy that even we are yet to learn.
check
Okay. Okay. Thank you, everyone. So I think we can drop off now. Have a good day.
Thank you, sir.
Thank you.